Hello students, welcome to my online class. Today we are going to work on sum and difference of angles for trig ratios. So we have seen these before in the formula sheet that I gave you. This is the formula sheet. You have some of the angle identities and difference of angle identities. So I just put them here just so you'll have immediate reference. So you can see some kind of pattern that goes on with some of the angles and difference of angles with sine and cosine. You can split a certain angle into a plus b or a minus b, but how does that break down? Luckily, we don't have to prove anything in this class. That's out of scope of this course for y'all. But sine of a plus b, if you see the pattern, so you can easily memorize it. Sine of a plus b, sine and cosine, cosine and sine. You see that? And the angles are switching. So what I strongly recommend you to do is remember this as sine of a plus b, right? I'm just talking about sine of a plus b. And then the a minus b will follow through. You would do sine of a, cosine of b. So you would do sine and cosine with a and b, right? Respectively. And this time you would do cos and sine, but with a and b still. See how they're switching for the second term? So you're starting with sine a cos b plus cos a sine b. That's how you would memorize it. And a minus b will follow through the same way, but except for that, since there is a minus here, there will be a minus here also. Okay? So that's with the sine pattern, where actually the sine and cosine are switching. So it's sine a cos, cos a sine. Okay? So, but cosine of a plus b, the cosine acts a little differently. Cosine of a plus b has minus in between, whereas cosine of a minus b has a plus in between. Okay, so I'm just trying to help you make out patterns so you can easily remember. The formula sheet will be with you anyway, but I'm just telling. Because when you see the other questions, like if this side is given to you and you're asked to find the left side, then you should be able to make the pattern out. That's why. So cos A, cos B. So the first term is both cosines, A and B with the angles respectively. And in the second term, you have sines of the same angle. So that's how you would remember. So cos of A plus B is cos A, cos B minus sin A, sin B. Whereas cos A minus B is cos A, cos B plus sin A, sin B. Okay? So that's with sine and cosine, and tan is a little different altogether. It has even a fraction in it. But this is also an easy thing to remember, because if you see tan of a plus b is tan a plus tan b, that's in the numerator. But in the denominator, it gets as a product with a 1 minus. So 1 minus tan a tan b. So here if there is a plus, there is a plus here too. If there is a minus here, there will be a minus in the numerator. Okay, and it follows through. So how are these useful to us? They are useful to us when we do not have a calculator handy, and also you have angles that are posed to you with which are totally unknown to you. So this is like sine 105, but I can look at 105 as something that I can bring it to a known angle by splitting it apart. So 105 could be thought of as 60 plus 45, right? So that becomes easy. So think of this as sine 60 plus 45. And then you can apply this here, okay? So you can split this as sine 60 cos 45 plus cos 60 sine 45. You see that? Sine and cosine, cosine and sine, but the angles will be in the same order. So sine 60 cos 45 plus cos 60 sine 45. And you know from the unit circle that sine 60 is square root of 3 over 2. And cos 45 is square root of 2 over 2. Cos 60 is half. And sine 45 is square root of 2 over 2. Since all of them are acute angles, they're in the first quadrant, so everything is positive. So now you can write this in two ways. And in Math Excel, you will see in both ways actually. Sometimes you would see these radicals multiplied and brought out as root 6 over 2. So now they have common denominator 4, right? And here it is root 6 and 1 times root is root 2. You could see this as the answer, or you could see answer where the square root of 2 is factored out because that's a GCF here. You can write this as square root of 2 over 4 actually. You can even bring out the 4 because the denominator you have 4 in both the terms. So you can pull that also. And you can write this as square root of 3 plus 1. So both answers are right. Okay, you can see either of them. Now let's look at the cos 165 scenario. I'm going to scroll it up a little bit so I can have more writing space. So this is from this. So again, cos 165, think of it as cos of 135 plus 30. I think that's the best I could think of. And Miss Madhvi, 135 is not an acute angle. That's fine, but you know what the values of 135, so keep your unit circle handy. Okay, so for this, now this is the cos of sum of two angles. So which means this is cos 135 times cos 30 minus sine 135 sine 30. Okay, so cos 135, it's in the second quadrant and cos is negative in the second quadrant. And this is negative root 2 over 2 times cos 30 is root 3 over 2. It's an acute angle, so it's positive. Minus sine 135 is positive root 2 over 2, but there is a minus here, so it will be square root of 2 over 2. And sine 30 is a half. Right? Again, you can write it in this way or that way. So I'm first going to multiply it through. You have a common denominator 4 and you can write it as negative root 6 minus root 2. Or you can write it as, see, here the common term is root 2 over 4. You can bring the negative also outside and write it as root 3 plus 1 because I'm factoring the negative also out. Okay, so that's how these problems go. So the catch comes when you're given radians. Oh, Miss Madhvi, how should I do this? The best thing I could suggest you is to first convert this into degrees. You know, that's what I would do. Save your time and stress and effort. So just convert this. This is 15 times. So 19 times 15, it happens to be 285 degrees. Okay, so 285. So 285 could be actually split into the nearest known is 225. You should look into the unit circle, my dears. You should have that handy. You see how important unit circle is? So 225 plus 60, isn't it? Is 285. So you can think of this as cos 225 plus 60 degrees. Okay, and you know pretty well that now this is cos of A plus B, meaning cos A cos B minus sine A sine B. So this is cos 225 cos 60 minus sine 225 sine 60. Okay, so this is in this third quadrant, 225. It's less than 270 and greater than 180. It's in the third quadrant, so cos is negative, and this is negative root 2 over 2. But 60 degrees is acute angle, so this is going to be positive. Sine 225, again it's in the third quadrant. Sine is also negative, so this happens to be negative root 2 over 2. And sine 60 is root 3 over 2. So here the negative times negative will become positive. The middle term will be positive. Okay. So this is, if you take the common denominator, negative root 2 plus root 6. Okay. So that's the answer. And you do the other one if you need. You can factor out root 2 over 2. Right? It's up to you. So that's how this goes. Okay, so now this is a negative angle. So let's convert it into degrees first. And so this becomes 75 degrees. But this is a negative angle. It's okay. So this is sine of negative 75. So you can split this as sine 45 minus 120. That's the best I can think of. And I will leave it to you. I want you to try, okay? You try it. You try. And I want you to skip this because at this level it's a little challenging. I want you to look at these kind of questions where, hold on, where did I go? Yeah, the seventh, these kind of questions where the split is given and you have to find out how to bring it into tan. So suppose tan 48 plus tan 102. So according to our formula sheet, the formula sheet, if you go on the top, you will see that tan A plus tan B and so on and so forth, meaning it's tan of A plus B. So now you're going on the other direction. So this will definitely be tan 48 plus 102. So what is tan of 48 plus 102? It's tan 150. And you will look into the unit circle, and tan 150 is actually negative root 3 over 3. Okay. Likewise, you have here cos A, cos B minus sin A, sin B. So it's definitely going to be 300 plus 15. Okay. Which is 315. So cos 315. So you will look into, let me write nicely, cos 315. So this is root 2 over 2. It's in the fourth quadrant and that's why it's positive. So when it comes to radians, it's still the same thing. Here sin A cos B minus cos A sin B, which means that sin 13 pi over 10 minus 2 pi over 15. So the only challenge here is to bring as a common denominator. So the common denominator would be 30. So you want to multiply and divide by 3 here and 2 here. So you will get a common denominator 30. So 3 times 13 is 39 pi minus 4 pi. So which is sine 7 pi over 6 after reducing it. And sine 7 pi over 6, look into the unit circle, it is negative half. Okay, this is how you do these kind of problems. And you can look at my key of this packet and check your answers. All right, thank you so much for watching. Bye.